Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on changing equilibrium conditions. Last time, we discussed the relationship between K subscript C and K subscript P. While K subscript C is the ratio of products concentration over reactants concentration, K subscript P is the ratio of products partial pressures to reactants partial pressures. We also distinguished between homogeneous and heterogeneous equilibrium reactions. We learned that heterogeneous equilibrium reactions are reactions that involve reactants and products in different phases. We also learned that homogeneous equilibrium reactions are reactions in which the reactants and products are present in the same phase or physical state. In today's lesson, we are going to learn about the effects that changes in concentration has on K subscript EQ or equilibrium constant. We will also discuss how pressure and volume tie into these effects. Let us get started. According to Le Chatelier's principle, as we have previously learned, if the pressure at equilibrium is increased, then the reaction will proceed in the direction where the pressure is being reduced. Since pressure is related to the number of moles, it also depends on the number of moles. Thus, when the pressure at equilibrium is increased, the reaction will proceed where the number of moles is reduced. If the pressure at equilibrium is decreased, though, the reaction will proceed in the direction where the number of moles is increased. For a general reaction, the equation looks like this. The effect of pressure is decided by a change in N. If the change in N is greater than 0, then the total moles of products are greater than the total moles of reactants. If the pressure is lowered, the reaction will favor a forward direction. More products will be formed at equilibrium if the pressure is lowered. Students, please describe what would happen if the change in N were less than 0.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. If the change in N were less than 0, the total moles of products are less than the total moles of reactants. Also, increasing the pressure will favor the reaction in a forward direction. More products will be formed at equilibrium if the pressure is increased. If you mentioned any of these results, good job! Let us continue. If there is no change in N, then there is no effect on the position of equilibrium. Let us look at an example. This equation shows the formation of ammonia. Therefore, an increase in pressure at equilibrium will favor the forward reaction. This equation shows the dissociation of dinitrogen tetroxide. Students, this video of an experiment will help you to understand Le Chatelier's principle more clearly. It involves the elements we just looked at in our last equation. As you can see, there is a syringe filled with a mixture of nitrogen dioxide and dinitrogen tetroxide. The syringe is plugged so that the gas cannot escape. The system is in equilibrium. Nitrogen dioxide is a brown gas, and dinitrogen tetroxide is clear. Therefore, when they are mixed, the color appears light brown. The more nitrogen dioxide there is, the darker the color gets. Thus, when the syringe is rapidly compressed, the nitrogen dioxide molecules compress, and the color becomes darker than it was before, and then lightens slightly. When the syringe is rapidly decompressed, the color ends up being lighter than it was before, and then darkens slightly. Students, let us do an activity. Please use Le Chatelier's principle to describe the color changes in this experiment.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. What answer did you come up with? When the syringe was rapidly compressed, the gas inside it compressed, so the color darkened. The gas then reacted to the pressure change by reducing the number of molecules, which is why the color slightly lightened. When the syringe was rapidly decompressed, the gas inside it expanded, so the color lightened. The gas molecules then reacted to the pressure change by increasing in number. That is why the color slightly darkened. In terms of concentration, if we increase the amount of substance at equilibrium, the reaction will proceed in the direction of where the substance is consumed. If we increase the amount of reactants, the reaction will proceed in a forward direction. If we increase the amount of products, the reaction will proceed in a backward direction. If the products that are formed are removed from the vessel in which the reaction is taking place, the forward reaction is favored. Students, let us look at an experiment that studies the effect of concentration on the position of equilibrium. We start by placing 5 test tubes in a test tube rack and labeling them 1 through 5. We put 50 milliliters of 0.05 molar solution of iron 3 nitrate into 1 beaker, 10 milliliters of 0.01 molar potassium thiocyanate solution into a second beaker, and 20 milliliters of 0.1 molar nitric acid solution into a third beaker. We then mix the solutions according to this table to create 5 different solutions in the test tubes. When the iron 3 nitrate is mixed with the potassium thiocyanate, the iron 3 nitrate reacts and produces a red solution. When the iron 3 nitrate is mixed with the potassium thiocyanate, the iron 3 nitrate reacts and produces a red solution. The potassium thiocyanate is a spectator ion, which means it is the same as a reactant as it is as a product. When we mix the nitric acid with the iron 3 nitrate, though, the higher the concentration of nitric acid, the deeper red the solution will become. By Le Chatelier's principle, the position of equilibrium shifts to the right to remove some of the extra thiocyanate. This creates more thiocyanate iron, and the solution's color deepens. In today's lesson, we discussed the effects concentration has on equilibrium. We used Le Chatelier's principle along with 2 experiments to show examples of the effects. We also looked at how pressure and volume changes can affect the equilibrium. This brings us to the end of our lesson for today. Until next time, thank you, teacher. Thank you, students.